This is Hallicrafters Rehabs. Welcome back. I did have a good visit with my 100-year-old father. He's weakening more and more each week. Right now he has a very difficult time using his walker more than a few feet. But that's to be expected. It happens when you get that old. But he can still get in the car and enjoy a ride, and hopefully with that we'll get him out and do an early vote next week. So if my dad can go vote, so can you. And also I've been communicating with my friends on the other side of the earth and hoping to strengthen those relationships over the next few weeks with some trainings and some just general Bible studies and things like that. So that's another activity that will probably take a little bit away from this stuff now that things are opening up. And they are opening up in other countries, I can just say that much, including some of the South Asian countries. So yesterday I did some work reconnecting the selectivity switch here, and we just have a couple of leads to go here, and then it will be in. You had to take each one, trace it on the schematic and find out where it links up into the set. So we'll finish that up, and a couple other things I did. If I can find that. Here it is. This was a 330,000 ohm resistor. I think it's a 2-watt. That's the resistor that goes to ground when you're in standby mode. And another case of picoamps going through a really oversized resistor was so big that you can't even see what you're doing on the rectifier when plugging that in. So I took that out. But that's where I'm at right now, and we'll come back to this with the next step. Okay, I've wrapped up the wiring in here, and I've gone through and done some of the QC check on the connections and things like that, but it's wrapped up. I'll do a little bit more of that and shake it out and blow it out and so forth. The next thing will be to clean this up a little bit and mount the main transformer. So we're going to take the clamshells off and take a look. The transformer is working perfectly fine, but this is bad. We're going to try this again. This is actually can't read it, 11/32 screw. So we'll just loosen these. We'll just address these leads a little bit. In 2017 I did not do anything with the transformer. I didn't know much about anything on transformers back then, so cleaned up quite a few since then. But this was, I mean, we aligned this set with this transformer running, so the trick is to clean it up without damaging it. Let's see. and losing all the parts. Supposedly, well, these drop out, and there's a nice spacer that you just want to keep. Inside there, it's made of, I don't know, cardboard, I think. This is in the exact same condition. I mean, it's not changed or been opened since the radio was built in the 50s. And these are coated with wax. They look in good condition. I'm not sure I'm going to need to put heat shrink on them or anything like that to protect them. And well, let me struggle with this off camera. It just needed a little bit of coaxing. I had to position my body in a way to do that with delicately, but it's coming loose. Pretty standard tube with rectifier. They all have rectifiers, but I mean, 5Y3 transformer, probably not too different from the SX-99, maybe a little more iron to it. So black, always black is the primary, green is the filament, always. Yellow is the filament to the rectifier. Multicolored is the ground. And the two reds are the AC, high voltage AC to the rectifier tube. So it looks good. I might just wipe it down a little bit and clean it a little bit. But I'm going to work on this a little bit. Avoid. I think we want to just leave that in there. And do a little bit of cleaning and get rid of some of this little rust bits and so forth and paint it. So the clamshells I just buffed out with 180 grit, then 600 grit, and that was sufficient for the kind of thick automobile acrylic black Rust-Oleum paint that I'm going to put on there. And on the underside, I just polished them off with some old mag, Mother's Mag aluminum wheel polish, which is sufficient for this purpose. And so we'll just put a paint, start painting that. Okay, so the transformer itself is cleaned and ready to go in. Primary. Heater, secondary, red, yellow, and ground. All right, so we're going to record for posterity. Zero this out. Not very zero, is it? Well, we're not measuring, we're going to measure ohms. So the black leads are the primary. Now, why is the 3.6 ohms? So why is the filament on the same side as the primary? Because just a few turns around the primary and you have just what you need. This is filament. 0.3 ohms. We should do the other measurement, which is, looks like 1.5 millihenries. 1.1. And let's go ahead and do the other one I forgot to do, which is the primary. All right. 0.25 henries. 250 millihenries. Okay. And of course, we better not have any short, no. Short, no. Short, no. Short, no. Short, no. Okay. And the filament? Short, no. Short, no. Short, no. Short, no. Okay. Now let's go ahead and measure the red secondary. And the red secondary, not the red to yellow. Okay. Looks like 133 ohms. And 6.3 henries. Yes. Puts out the power, huh? Is there any short to ground? Yes, it's not short, it's a center tap. So, center tap. 1.65 henries. 64 ohms. And then we'll do the other center tap. 69 ohms. And 1.67 henries. Now we'll take a look at the secondary. Secondary filament for the rectifier. Let's bring that down. 1.6 millihenries. .4 ohms. And is there anything to the center tap? I don't remember. The answer is no, there's no connection to the center tap. The center tap is related to the red secondary, or the high, whatever you call it, high current AC secondary has a center tap. No center tap on the filament. So it checks out. I'm still drying the clamshells. This is prepped and ready to go, and we'll put it all together tomorrow. Okay, it's time now to reassemble the transformer, So I put these in here to help get the leads through the holes. And it's a grommetless entry, so what I do for that is I have a little piece of heat shrink that I put over it. One side has the the green and the black. And this is supposed to help instead of cause a problem. Quicker way to deal with this is to just cut this. Because I don't need but a short length. And the other, should have done that first because it's longer. Okay. And we just fish it through. There we go. Just ease it down. There's another piece of heat shrink right here, and this I'll push down as far as I can, and we will shrink it, and that will be, quote, the grommet. Little extra protection right around that interface. Okay, so bring the other clamshell through. Now, inside the set, if the set is over here, then this will be the bottom right there. So what I want to do is something a bit surprising. I'm going to put these in right here. I hope this is good. This is actually an idea I have to deal with the fuse. Because this time I decided not to drill another hole for the fuse, but to use the existing holes that are there. And we'll just get this in here just to get started. Same for here. It may, or I think it'll work. And what we'll do is we'll splice this into the power line, and it'll be on the top side of the set instead of inaccessible, but still safe from electrocuting anybody. And we won't actually anchor it, but we will fasten it with tie wraps to these holes here I'm putting in. And I kept this paper, waxy paper, sleeving around those screws. I think it works, it creates less vibration, if there is any. This comes off. That was just to help me get it through the hole. Here we are. Red, yellow, ground, filament, and power. Standard fare. This I just cleaned with some Scotch-Brite, nothing more, and it's not painted. Yes, the head of the screw is on the top of the transformer, and this is on the bottom because that anchors with the chassis. So now I'm going to go get the chassis and we'll mount the transformer. Okay, so we're ready to mount the transformer. The green and the black go this way. They go that way. Oh, I'm sorry. It goes that way. For once, my fingers operated delicately. the screws were put in wrong. Alright, so I had it 90 degrees off. This is supposed to go here and that's supposed to go here. So let me make that correction and we'll come back. Alright, after that brief interlude, they're on the right side, or 90 degrees different, and we'll do this again. Right. Let's just do this. Fortunately, it's not difficult to start these nuts on these screws. For some reason, they seem to be designed to not be so difficult. All right, we are in, and we start the wiring process. Either end of black goes into neutral here. My little capacitor is still there. Oh, okay, good. It's sort of weakly dangling there, so I have to bring it around. Okay, so it took some time. I actually had to pull this back out and pull this capacitor out in order to get these seated properly. I'll trim this off once it passes the test. So we have the black going to neutral, black going to the return from the inrush current limiter. You have the ground, this is ground, and there's one green lead which is ground. Then we have standard 5Y3, we have a yellow to pin 8 and a yellow to pin 2 and a red to pin 4 and a red to pin 6. So the acid test is about to become what is B plus to ground. That would be here. Oh, turn it on. Alright, it's isolated from ground. We don't have a tube in there, so I bet you I would measure something, but so the yellow measures down to the 200 ohm scale. .3. The red 136. Okay. The green, hard to get in there. Only 6. All right, so we're going to run. Oh, we now have some wiring to do on the other side. Okay, so that took some effort. Let me tilt this over a little bit so you can see. So what I did was I brought this through, and I actually had to put a little heat shield there. I was concerned about that. It just mounted right into those little holes there with some small screws, because this is the 6K6, and that's a pretty good heat generator. And so we got some clearance and we got some shielding, and so I'm sure there's not going to be any issues with that. It's really important that there isn't, because that's AC power going through there. Just tightening one more time. But that was the plan all along, not to have to drill another hole in the back of the thing in order to have a... I just don't like the idea of taking a radio out of the case just to change a fuse. So 2 amp fuse inside there, 250 volts. So we're in great shape as far as fuses and things like that. So I'm going to turn it over and test it. Okay, so just checking the continuity through the power plug. That's off, on. Okay, so that means that we're good all the way from here through to the switch back to this little unit here. I wonder what that resistance is. So it's 150 ohms or 140 ohms. 4.4 ohms of the inrush current limiter, which is outside the field of view here. I was just curious to see. Oh, there it is. Okay. Right in here. And then when you go through it, there's 136 ohms. So AC is working. No, we're not shorted to ground. Just check this side. No. All right. So it works. And we'll move on to the next thing. Okay, the next thing we're going to tackle is this crystal calibrator. And everything's in there pretty tightly. We got this one 50, it's like a 57 or 58,000, 580,000 ohm resistor, and one 4700 resistor here, and these just simple capacitors here. There's a 100,000 ohm resistor there, and a 220,000 ohm resistor there, and this mica. So we're just going to desolder and take a look at things. just go from here. Okay, so the bottom line is the resistors were out, and so I replaced them. The capacitors were fine, so I left them in. And to desolder these, I put my desoldering tool right on the tip and the other iron as well, and just kept heating and sucking out solder until you could pull out the component. And then you put it back in. You clean all of the insides of this out, and you add solder in layers. Let it sink down, then let it cool a little bit, and then put some more, and so forth until you've filled it up. So that is the crystal calibrator, and it just goes into the box like this. Like that. It doesn't go in the box like that. It goes in the box like this. How about this? Okay. Yeah. So then you do the side screws here and then put it on the radio. Let's see if we can do that real quick. And this radio will be ready for DC resistance checks. Well, not yet. We got to put the tuning capacitors on the front. On the top. And that will take some time, so we'll be doing that next week. Here, tightened it too soon. There we go. And do this one. It's a fat one. Uses a thin one, small one. So, the box is ready to go. Then I'm ready to go and catch the last few laps of the race. This is Hallicrafters Rehabs. Thanks for watching.